Hey guys, here we are, starting chapter 3, lines and angles. Sorry that you have 2 videos after a test, but it's just how it is. Okay, the first thing we're going to talk about is parallel lines. They are 2 lines in a plane that never meet. They never meet. The symbol to represent parallel is these 2 little lines. They look like 2 little lowercase l's side by side. All right. And then there's also a symbol to represent parallel, just like how we've represented congruent before. If we saw these 2 lines and we wanted to assume that they were parallel, we would have to look for these little arrows. Notice how this has 1 arrow and this has another arrow? These 2 lines are parallel. But if you look over here, these 2 lines, this has 2 arrows and 2 arrows. So it would be these 2 lines that were parallel to each other. That is parallel lines, and this little arrow tells me they're parallel. All right, we move down to skew lines. And skew lines are 2 lines that do not intersect and are not in the same plane, and they are never parallel. So the best way to look at skew lines is look at a cube or draw out a cube and see how this one's going straight up and down, and this one's coming at a little horizontal angle. Those would be skew lines. Another example would be when you're driving on the freeway and you drive over an overpass. The street or the road that you're driving on and the overpass going over the top would be 2 skew lines. And that's skew lines. Okay, parallel planes. Planes this time, not lines that do not intersect. So again, another cube with the top and the bottom are parallel. Parallel planes. Transversal. Okay, this is where you need to start paying attention a little bit more here. It is a line that intersects 2 or more lines in a plane at different points. So here's one line, and here's another line. This line that I highlighted in green, that's your transversal. It intersects this line at one point and this line at a different point. A transversal. It cuts through 2 lines. Okay, let's look at this example. It says name all the planes parallel to EFG. So here's EFG right here. The only plane parallel to it would be this plane down here, ABC. And then it says name all the segments parallel to EF. Well, here's EF. So everything I've highlighted in pink, GH, DC, and AB would all be parallel, right? They'd never touch, and they'd all be parallel to plane EF. And then it says name all the segments that are skewed to AG. So remember, it never touches it. Well, AG is right here, highlighted in green. Okay, this plane DC, I know that looks like it touches it, but remember this is a dimensional cube, so DC would be skew, BC would be skew, EF would be skew, and FH would be skew. Those lines would all be skew to AG. They would never come in contact with it, and they would not be parallel. Okay, this is geometry right here, guys. Interior and exterior angles. All right, interior angles lie inside of the plane. So I went ahead and highlighted them in green and marked the interior of these 2 lines with green where the interior angles are. All right, and then we have the exterior angles, angles that lie on the outside of the lines. So I went ahead and called this line L and this line M. And all the angles that are outside where it's orange, angles 1, 2, 8, and 7, they're all exterior angles. So that's a special angle formed by transversals. Okay. Now we're going to talk about interior angles, but we're going to take it a step further. We're going to say that these are alternate interior angles. Non-adjacent, remember they're not touching, interior angles that lie on opposite sides of the transversal. So alternate interior angles here would be angle 4 and angle 6. They're on opposite sides of that transversal. Here's our transversal that cuts through them, and angles 4 and 6 would be alternate interiors. 3 and 5, 3 and 5 would also be alternate interiors. We're going to move down here and talk about exterior angles, but I'm going to need this picture still. So alternate exterior angles. Non-adjacent exterior angles lie on opposite sides of the transversal. So they're on the outsides of the transversal, but opposite sides. So angle 1 and angle 7 would be alternate exterior angles, and angles 2 and angle 8 would be alternate exterior angles as well. Then we move down here to talk about same side interior angles. All right, same side. So we have two lines and we have the transversal that cuts through them. Same side interior angles must be on the inside of the lines and on the same side. So 4 and 5 would be same side, interior, inside the lines. And our other set would be 3 and 6. Same side, interior, in between these two lines, angles. And we're moving on to the last of them, corresponding angles. So that means they are in the same place. They lie on the same side of transversal and in a matching position. So if I'm looking at these four angles, I notice the angle 1 is in the top left-hand corner. So if I move down to look at these four angles, I would notice the angle 5 is in the top left-hand corner. That means the angle 1 and angle 5 would be corresponding angles. They're on the same side and in a matching position. If I look over on this side, I see the angle 2 is in the upper right-hand corner. And I move down here and I see the angle 6 is in the upper right-hand corner. Well, angle 2 and 6 would be corresponding angles. The same goes for angle 4 and angle 8. They're in the lower left-hand corner, and 3 and 7, lower right-hand corner, lower right-hand corner. So again, a lot more vocabulary for you guys. And that's it. On to the next video.